Welcome to iLecture Online, and in our next example we see something slightly different, and let me show you why. We have two equations. One is x equals y squared, the other one is y equals x minus 2. So let's find the area bounded by those two equations. So first let's graph them to see what they look like. And x equals y squared is a parabola that is pointed sideways like that because the exponent is not on the x term but on the y term, so that parabola looks like this. And therefore this is called a relation, really, not a function. And there's a straight line, y equals x minus 2. The y-intercept is at minus 2. The slope is 1, so it looks kind of like this. And notice that those two equations cross right there and cross right there. And there's the area bounded by the two equations. Notice that the way it's situated like this, if you take your area element and you make it vertical, on this part of the area, the top of the area element would be bounded by this line and the bottom would be bounded by this line. But when you come across here, past this line right there, notice that the top and the bottom of your area element are not bounded by the same equation. So that means you would have to do two integrals, set them up differently, and go from this limit to that limit and from this limit to that limit. You don't really want to do that if you can help it. It's better to set up your area element sideways like this. Because if you set up your area element sideways like this, so there's your little dA, that means that the top and the bottom of the area, or in this case the left and the right side of that little area element, will be bounded by the same line all the way through from here to there. And so what we can then do is integrate or sum them all up, going from this point to that point in the y direction. So let's do that. So if we call this point right here x2 and this point right here x1, my area element is now going to be x2 minus x1. The reason why I put x2 first and x1 last is because this will have a larger x value and this will have a smaller x value. So when I go x2 minus x1, I get a positive quantity right there. And then my width here is my dy. Okay, now we still have to define what x1 and x2 are, and I'll do that in just a moment. Now let's also find out where the two lines cross right here, which means we have to solve these two equations simultaneously. So what we can do is we can say, okay, this x right here is equal to y squared from the other equation, so we plug that in here and solve that for y. So let's do that. So that means we get y is equal to, instead of x, I'm going to write y squared minus 2. That looks like a quadratic equation in y, so let's solve that, and that'll have two roots. And those two roots will give me the two y values of those 2 points. So when I move everything over to one side, I get 0 is equal to y squared minus y minus 2. And that looks like we can factor that. Let's try. So 0 is equal to, I get y minus 2 and y plus 1. So let's see if that works. Y times 1 is plus y, that's minus 2y, that's minus y, that's minus 2. Looks like it's a go. All right, that means in the first case we have y is equal to 2 or y is equal to minus 1. So those are the two y values where the two equations cross. So right here that looks like y would be 2, and over here that would be like y is a negative 1. I still need to find the x values for those two. Well, not really, but just to make it a little bit easier to see. If y is equal to 2, that means x must be equal to 4. I get that from that equation right there. And if y is equal to minus 1, that means x must be positive 1. So from this equation, it's easy to find the two x values of those 2 points where the two lines cross. Okay, now that I have my limits, I can go ahead and try to integrate that. So my total area is going to be equal to the integral of all my d areas. And of course, I'm going to integrate from y equals negative 1 to y equals 2. And my dA is equal to the integral of my x2 minus x1 times dy from y equals negative 1, there you go, to y equals 2. Now, of course, if I'm going to integrate over y limits, I need to replace the x1 and x2 by their equivalents in terms of y. So notice that x2 here is bounded by the straight line. That means that this is my x2. If I solve this x2 in terms of y, I get from this equation, I can say that x2 is equal to, I'm going to write a sub 2 there, y plus 2 when I bring the minus 2 over to the other side. So instead of x2, I can write y plus 2. So this is equal to the integral of the quantity y plus 2 instead of x2, and I'm going to subtract from that what my x1 is equal to. So this becomes my x1, and my x1 is equal to y squared, so it'll be minus y squared. So that's my x2 minus x1 times dy, and my limits are from y equals -1 to y equals 2. And now I'm ready to integrate. If I integrate that, I get this is equal to, that would be y squared divided by 2, so I add a 1 to the exponent, divide by the new exponent. Then I get plus 2y, and minus y cubed divided by 3. Again, I add 1 to the exponent, divide by the new exponent. And then I have to evaluate that from y equals -1 to y equals 2. So from -1 to 2. Okay, let's now come over here and let's evaluate those limits. When I plug in the upper limit, what do I get? I get 2 squared divided by 2, and that's a very small 2 here. Let me do that again. So I plug in a 2 for y, and I square that divided by 2, plus 2 times 2, minus 2 cubed divided by 3. All right, so now I plug in the upper limit. I'm now going to subtract when I plug in the lower limit. So minus, when I plug in the lower limit, minus 1 squared, that would be plus 1 divided by 2. When I plug in the lower limit here, I get a minus y, or minus 1 times 2, or minus 2. When I plug in the lower limit here, I get y cubed, that's minus 1 cubed, which is minus 1, times a minus 1 would be plus 1 over 3. Okay, so simplifying that a little bit more, I get 4 divided by 2, which is 2, plus 2 times 2, which is 4, and minus 2 cubed divided by 3, which would be minus 8 over 3. And over here, minus a half. I have minus times a minus, which is a plus 2, and minus a third. Okay, we're almost there. So I have 2 plus 4 plus 2, that is 8. And minus 8 thirds, minus a third is minus 9 thirds. And I have minus a half. Of course, 9 thirds, that's equal to 3. 8 minus 3 is 5. So I get 5 minus a half, which is 4 and a half. And there's the area between those two functions, or I shouldn't say functions, between those two equations. And again, the best way to do it is to set up your area element sideways so that the length of it is x2 minus x1. Define x2 as being part of this equation right there. x1 is the x of this equation right there, of the curve right there. So the length is x2 minus x1, and then replace x2 and x1 by what x2 and x1 are equal to in terms of y. And then you just integrate over the y limits, and you get your area. That's how we do that.